Hey, top penalized math and history, and we are going to be identifying a quadratic curve. Not a line, because literally, it is actually a curve. So, what we're going to be doing is identifying the characteristics of the quadratic curve. And there are many ways to describe a curve. We can definitely say that these curves are called parabolas, and they usually come when you have the equation y equals x squared. That is a common curve you will see in your high school years. But there are many different ways of identifying them. There are the vertex, axis of symmetry, the direction, the minimum or the maximum, the y-intercept, and the x-intercept. So what we're going to be doing is going from top to bottom into understanding what these are. So let's try and look at the vertex. The vertex is one of the first things you do when you try to understand a quadratic curve. And when you find that vertex, it's right there at the tippy curve point where the two lines, this straight line and the curve, meet. Usually where they meet. So right there, we're gonna put a point right there. So it looks like, since it's y equals x squared, we can normally say that the vertex can be 0, 0. In other case scenarios, sometimes you won't always see y equals x squared. Sometimes you will see more lines or curves that don't always fit 0. When you try that, you try to find a vertex right there. And instead of being at 0, 0, it might become a different point, such as -1, -1, 2, 3, 4. For this one, it's -1, -4. So that's the vertex. That also dives down to our second subject, the axis of symmetry. The axis of symmetry is basically when you fold, or when you try to fold, the curve in half. Let's say we make a horizontal line, and if you ever learned what symmetry was in your elementary years or possibly your middle school years, symmetry happens when there are two things that are the exact same shape and the same size. When you fold in half, or when you see a mirror. Here's an example. So, here is an example where a shape would be symmetrical. If you put a line down here, symmetry happens when both sides are exactly the same. The newer logo that we have is not symmetrical because the left side is a little bit uneven than the right side. So this example is not symmetrical. You can definitely try and fold a quadratic curve however you want. But in this case scenario, we use the vertical axis and use the point x equals to indicate where the line is. In this scenario, x equals 0. So, we're gonna put x equals 0. But why x equals 0? When you have a vertical line, you are always trying to understand where it is. So let's say x equals 0 right here. If you say x equals 9, then your axis of symmetry is going to move. And your axis of symmetry, you will actually shift the entire curve to the right. If it's a negative, to the left. Here's an example. So that is an example. When you try to have like a 2x or a 9x at the end of x squared, you will move the quadratic curve. That goes into the next one, which is actually self-explanatory because it's the direction. It's telling you where the direction of the curve is going. So is it going up for this example, or is it going a bit down like a frowny face? Well, in this case scenario, for this one, it's going up. So all we need to do is go up. There's nowhere to go, but what we're going to do is write the word up. So when we talk about direction, it also links to the minimum and the maximum, because when you have a quadratic curve, it doesn't always have to be up. It can also be down, however you want it. But a curve can only have one minimum or one maximum, because when you have it faced up, the minimum is going to be on the bottom right there. The maximum, well, there is no maximum because it keeps going up and up and up and up and up, all the way to the sky. But the other one, this one does have a maximum because it stops right over here. But instead of having a maximum, well, it has a maximum right there. Instead of having an infinite maximum, it has an infinite down, 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 into the Earth's core. Here's an example where that would happen. So that is the minimum and maximum. The last two ones are both almost the same thing. The x-intercept and the y-intercept. Let's start with the y-intercept, because that's more common when you go to high school algebra. And when you find slopes and curves on a graph, there are probably going to have teachers saying, "What's the x-intercept?" or "What's the y-intercept?" That means when there's a point on the curve or a line that intersects or strikes through the x-axis or the y-axis. Right here, this one has a y-axis or an x-axis because it strikes through the point 0, 0, as in x and y, for example. Let's try this one. Here's another example. The y is right here. So we're going to move the dot over here because this is not a perfect quadratic curve. Let's assume the dot is right here. So that is 1, 2, 3, 4. So the y-axis is 0, 4. Or that's the y-intercept. But sometimes you can have two x-intercepts. The x-intercept is when a curve or a line strikes through the x-axis. But with a quadratic curve, you can have two of them. Here's one right there, and here's another right there. What we can do is we have 2, 0 as our right one, and we also have 1, 2, 3, 4, 5. Negative 5, 0 as our second x-intercept. So a quadratic curve can have two x-intercepts. That is how we can find the intercepts. And that is how we can analyze and understand a quadratic curve. I hope this video has helped you. Thank you for watching Tao Penguin's Math Mystery. Like and subscribe. And sorry about the middle thing. Have a nice day!